Good morning, good afternoon, or good evening. My name is Anthony, and on behalf of my co-authors, Christian, Mohammed, Ali, and Fabio, I will be presenting our work on the refactoring of unit test files in Android apps. In this study, we look at the refactoring operations developers perform on test suites and the relationship between these refactoring operations and test smells. When it comes to software maintenance, prior research has shown that refactoring is not only an essential task but also a common activity. Refactoring can be as simple as renaming a variable to more complex operations such as extracting a class. One of the main reasons developers refactor code is to correct bad programming practices, which are also known as smells. And smells are a threat to design. By refactoring code, developers improve the quality of the system without altering its behavior. Test files, like production files, are also subject to smells, or, in other words, bad programming practices, such as violations in XUnit guidelines and concepts. Test smells were first introduced in 2001, and throughout the years, researchers have been adding additional smell types to the test smell catalog. Researchers have also studied the evolution of smells and looked at ways to eliminate smells from test files. There has also been work on tools to detect test smells. And finally, most of the studies on test smells have been on traditional Java systems. With smartphone ownership on the rise, mobile apps have become a productivity aid to everyday life. Furthermore, given the ease of app development, it is now, more than ever, essential for app developers to continually maintain their apps. These apps, like traditional systems, are also prone to smells. And with little knowledge available on the impact of refactoring activities on test smells in Android apps, our study initiates the research on how Android app developers refactor test code. Hence, the goal of our study is to understand how refactoring activities influence the stability of test smells in Android apps. To arrive at our goal, we look to answer three research questions. The first looks into the type of refactoring operations applied by developers to test and non-test files. We want to know if developers treat test files differently from non-test files. Archive 2 aims at understanding what types of refactorings tend to co-occur with a test smell. And finally, in Archive 3, we look at the types of refactoring operations that are involved in the removal of test smells from the test suite. From this study, our contributions include an understanding of refactoring operations applied to the test suites of Android apps, as well as the relationships between refactoring operations and test smells. And finally, we make available our complete data set for replication and extension purposes. To answer our research questions, we utilize an existing data set of test smells in open source Android apps. This data set was part of a study we published in 2019. The dataset contains the existence of 19 smell types in the apps. Next, we utilize a tool called Refactoring Miner to mine the refactorings in the apps and build a dataset of refactoring operations. Refactoring Miner is a well-known and popular tool in the refactoring community. Finally, we analyzed the contents of the two datasets. Our dataset consisted of over 4,000 refactored files in 250 apps. More stats around this dataset is available in our paper. Our study looked at 19 test smells and 39 refactoring operations. Examples are shown here. The smells have been part of our prior study, while the refactoring operations are those that are supported by Refactoring Miner at the time we conducted our experiment. In RQ1, we looked at the refactorings in test and non-test files. What we show in this slide are the top 5 refactorings for test and non-test files. The complete listing is available on our website. Our first observation is that the top 5 refactoring operations in test files account for 65% of all refactoring operations, while the same for non-test files account for 42%. In test files, the majority of the refactoring operations are clustered around data type changes and identifier renames. Next, we see that most of the refactoring operations in test files are applied to methods. This is not surprising, as methods are key components of test suites. For non-test files, we see that operations are more evenly split between methods and classes. Finally, as can be seen from the table, test files undergo more renames, while non-test files have more design level changes, such as move class. RQ2 looked at the co-occurrence of test smells and refactoring operations. To conduct this analysis, we extracted test files that had only one smell and then looked at the refactorings applied to this file. We show a subset of the data in the table. We see a high co-occurrence between method-based refactorings and test smells. For example, extract method and the lazy eager test smell deal with methods. An outcome of this analysis is that developers should focus on test smells being exhibited by the methods they are refactoring. You can also see a co-occurrence between general fixture and change attribute type. Developers should pay close attention to the attributes they are updating, as these may be used within a test fixture, that is a set of methods, and hence impact test methods. The final RQ looked into the types of test smells that are eliminated when a refactoring is applied to a test file. To do this, we looked at the lifetime history of a smelly test file and captured instances where the smell reduced and a refactoring operation was applied. As shown, we analyzed 481 such instances. On average, one smell was removed when a test file was refactored, and around 2 refactoring operations were applied on average to reduce the smell count. In most cases, a single refactoring removed a single smell type. Change variable type was one of the most common refactorings applied when a smell is removed, while eager test is frequently resolved when performing a single refactoring operation. We also performed a manual review to gain a further understanding on the removal of smells. We report findings in our paper. For example, we saw that developers apply an extract method to resolve the conditional test logic smell. This is a smell that occurs when a test method contains conditional statements. Our analysis also showed that when developers apply refactorings, the primary reason is not to resolve smells, but for some other reason, such as fixing a bug. Hence, smell removal is more of a byproduct. With regards to the takeaways from this study, RQ1 showed us that developers treat test and non-test files differently with regards to refactoring operations. For instance, non-test files undergo more design or structure level types of refactorings, unlike test files that are limited to somewhat cosmetic updates, such as renames and type changes. From the findings of this RQ, developers are better prepared to handle and estimate rework for test and non-test files. RQ2 explored the co-occurrence of refactorings and smells. Our findings showed interesting patterns, such as a high co-occurrence between method-based refactorings and test smells. From this, developers are better prepared in determining the most likely smell being introduced when refactoring a test file. Finally, RQ3 shows us that test smell removal is mostly a byproduct of refactoring the test suite. Past research has also shown that not all developers perceive all test smells as problematic, and hence, more research into this area is warranted. In closing, our study looked into the refactorings of test suites of open source Android apps and the relationship between test smells and refactoring operations. We observed that app developers apply a different set of refactoring operations to test and non-test files. We also looked at the co-occurrence between test smells and refactoring operations and the elimination of smells in test suites. This brings us to the end of the presentation. For more details about our research into test smells, including our open source test smell detection tool, please visit our website, testsmells.github.io. Thank you.